On page 79 in your notes, we're starting section E, which is mechanisms for evolution. And what we mean by mechanisms is the how and the processes. How exactly does evolution happen? And the first thing that we want to start with is the idea that populations are what evolve, not individuals. Remember, an individual cannot change their DNA. And so here's a really good example. Let's say that we have a bird, and the bird is eating the beetles. And the bird can most easily see the green beetles. So it's going to eat mostly green beetles. And what we'll see over many generations is we're going to see a lot fewer of the green beetles. And so a whole group can evolve or change over generations, but an individual does not. So the population is the smallest unit of evolution. Different versions of not acquired, we need to change this to inherited. Different versions of inherited traits are present in a population and can be selected, thus changing the population. What this means is that your DNA determines your physical appearance. And so what we see is that when we have a selection force, the predator is the selection force, the environment is the color of the beetle's background, and we see that the selection force is going to select who survives. And thus the selection force affects the population and how we see the whole population. So when we look at how evolution happens, it happens by changes in population, not changes in individuals. The next thing that we want to see is that evolution happens when there are changes in the gene pool, and that happens by mutations. Mutations are changes in the DNA of an organism, and so we're only going to see mutations that affect the phenotype. Some mutations are what we call silent. Some mutations have no effect or are silent. So only the mutations that actually change the phenotype and produce variation. Remember, in order for evolution to occur, we must have variation. And so for evolution to occur, mutations need to occur, and those mutations need to cause variation. So you can see here in this picture that we had an original population, some random mutations that gave us variation, some faster rabbits, some slower rabbits. Natural selection selected the faster rabbits, which continue to reproduce, and any variation that is a disadvantage does not survive. So it is important for us to know that in order for evolution to happen, we have to have mutations. We also have to have environmental changes. And what we mean by environmental changes are selection forces. Something has to be doing the choosing. What gets to survive? So we have variation, but something needs to choose what gets to survive. There are three types, or we're going to say patterns. Three patterns of natural selection. The first is called disruptive. Conditions are most favorable for both of the two extremes. And so what this means is that the average has a disadvantage. The average or the middle has a disadvantage. bunnies and white bunnies and gray bunnies. The middle, or the average, the gray bunny would be a disadvantage, and the black and the white would have an advantage. Two other patterns that we'll see. The first is called stabilizing. Conditions are most favorable for the average condition, meaning that the average is the most successful, and that's called stabilizing. And then we have directional, which is where conditions are most favorable for one of the two extremes. So we move in one direction. So next, there's a really good picture that can help us see what these look like. Here's disruptive selection. Disruptive selection, this is before and this is after. So this is really the pattern. I want you to trace this pattern. When we have disruptive selection, the middle, the average, does not survive. See how there aren't very many in the middle? Stabilizing selection is where the average is successful. It's better to be the average. And directional selection is where one direction, I want you to trace this pattern. One direction, one type, has the advantage on one end. So we're going to do some examples of disruptive, stabilizing, and directional selection. But these are the patterns that we sometimes see in natural selection. The third how about evolution is called speciation. It's the development of a new species. And it's usually because, so we want to add in here most often because of geographic isolation. So geography has to do with distance, and isolation means to be separated. So geographic or distance, isolation or separated. So if we divide the population, they might evolve differently, leading to a new species. One of the most common examples is the Grand Canyon. Now the Grand Canyon was carved out by a river. It used to just be a river that ran through that part of the United States. And that river no longer exists, and so the land is separated by this huge canyon. And there were squirrels on one side and squirrels on the other side. If we put those two squirrels together, they can't mate anymore. They're so different from each other. And that's because they were separated by space. Now they are different, they can't mate, so we have new species. And if you look at their scientific names, you can see they're in the same genus, but they're in different species. The fourth thing that we need to know is the time frame. Time frames describe how quickly a new species may have formed, mostly based on the fossil record. The first time frame that we see is gradualism. Small changes occur constantly until a new species is formed. So this is a really good picture because it shows us, for example, this butterfly or moth. And we see some mutations. We start to see that they're different. And these mutations occur all the time, but they slowly result in two different species. And so we call this gradualism because gradually also means slowly. So small changes occur constantly until a new organism is formed. We want to add into this slowly over long periods of time, or we could say over many generations. So that time frame is called gradualism. And then we have something called punctuated equilibrium. Punctuate think of like a comma, like the punctuation mark, a comma means to pause. So punctuated equilibrium is where we have no changes for a really long period of time, and then all of a sudden drastic changes. And so all of a sudden we end up with new species. A lot of time punctuated equilibrium is because of an extreme environmental change. So if there's a huge volcanic eruption and the environment has drastically changed, that will force natural selection to happen a lot faster. And so those are how the two patterns of time about how evolution will occur. That's the end of this unit, so you want to take some time to complete your summary box.